Hello everyone. In this tutorial I'm explaining the sixth lab cycle program, which is to find the largest or smallest number in an array of 32 numbers. Let's look into the concept. First of all, we are going to define a constant using a assembler directive called as a DCD, which will going to define the data as a 32-bit number. That means it will going to set a 4-bit memory boundary location. Not 4-bit, it's a 4-byte. So that means 4-byte, which is equal to a 32-bit. So whatever we are doing a comparison, or we are going to find the largest or smallest number in an array, that will be for a 32-bit number. And the next thing is to define a variable which is to hold the address of the internal RAM in which we are going to store the results. For that, we are going to define one more variable which is called as a result. I'll show that in our program. The third step is to initialize a counter to do the comparison between all the elements of a array in order to find out a largest or a smallest number. So before doing that, you just keep in mind that if the size of an array is n, the number of comparison we do is n minus 1 time. So just keep that in mind. That's why we are going to reduce that counter to n minus 1 time. So after every comparison we do, we will going to decrement the comparison counter. So now let's see how exactly it will going to work. See, now I have taken a 6 32-bit numbers. So which for that we are going to give a constant name as an array, which has been defined with an assembler directive called as an DCD, followed by a 6 32-bit numbers. So what exactly we are going to do is, the first element in this array will going to be compared with all the elements in array, and while doing that, if the first number is smaller than the second number, we'll going to exchange both data, and will again, whatever the data that has been exchanged, or the largest number, that will be compared with the remaining elements of the array. So if you are doing the if you want to find the smallest number in an array, we have to do the vice versa. That means if the first number is smaller than the if the second number is smaller than the first element, we are going to exchange it. So now let's come to the program. Let's see. In this, you know about these assembler directives. We are going to define an area on the program region program code by giving it with a name called as a largest. In this program will going to find the largest number in the given array. So now let's start with the program debug mode. So I'm going to translate and build it. Then I'm going to enter into a debug mode. Again, I'm going to select it into a memory location. Why? Because I'm just going to store that whatever the result that is coming from either to find the largest number or smallest number, whatever the result that will be in either program, that result will be stored inside the internal RAM. So I'll start executing with the first instruction. The first instruction is to initialize the counter. That is, the number of elements in an array is 6. That's why okay, the number of elements in an array is 6. Now I've just defined that counter, which is R5. The R5 register has been used as a counter, and it will be loaded with the value 5. Because why? Because I'm just using a 6 numbers, and I have to do 5 comparison. As you can see, the first number will be compared with the second one comparison. Again, this number with this 2, again this number with this 3, this with this 4, and this with this 5. So if the size of an array is n, now the counter will be like, or else we do a comparison operation for n minus 1 time. So let's come back to the program. So now with the first instruction, I'm just loading the counter. That means R5 is used as a comparison counter, and in the second instruction, I'm just loading that address of an array. This constant, whatever a constant has been defined with the name of an array, that address will be stored inside the R1. So this instruction, or this array, will going to make use of a internal ROM, internal ROM memory. Again, you have to remember this one, which is that keep in mind about this diagram. When I say I'm going to use internal ROM, that means where the program will going to be stored, it will going to use the address between this 0002 this 0007 FF. So within this region my internal program will be stored. Since my array has been defined inside the program will going to reside inside the program ROM. So now that address will be stored in the R1. This address will going to vary from program to program. Don't try to memorize it. Now the address of the array has been given, has been setted, or it has been loaded to the R1 register. Now I'll just move into that address location. What is that? 00000034. So when I get into this region or this memory address, I should find whatever the element that has been defined inside an array that should be present in your memory location. So as you can see, all the elements that has been defined in array are present in this memory location. So I'll come back here. Now what I'm going to do is I'm going to fetch the first data into a register R2 and the second data into R4. Then I'm going to compare it. Remember, I'm going to compare the first element with all the elements in an array. In order to do that, I have to fetch the first element into an one register and second element into a second register. We'll do this comparison operation if I find that the second number, as we are writing a program to find the largest of a number. So the largest number will be compared with all the elements of a array. So if the second number is greater, I'm just going to exchange these two. Let's see how exactly it will going to work. I'll come back to my main program. So I'm going to get the first data. So in this instruction, what I'm going to do is the R1 will be updated 4 times. As soon as I'm going to load that first data into R2, it will auto incremented by 4 times, or else these two the address will going to be added with a 4 and the data will going to be get inside the R2. So first element has to be come into R2 register, which is nothing but a 4444. The second element has to go to R4. See, now R4 has been setted with the second element. The first element is 4444, the second element is 22. Now I'll do the comparison operation between these two. If the second number is larger, then I'm going to replace that, or I'm going to exchange both the elements. The position of the elements will be exchanged. Let's see. In the next instruction, I'm going to compare 4444, that 4 with a 2. So since the first element is greater than the second element, we are not going to perform any comparison operation. We are not going to do any exchange operation. As you can see here, when I'm going to execute the compare instruction, I'm going to check if the higher number, if the first element is higher number, then the program has to jump to a label loop 1. That means we are not going to exchange if the first number is greater. Only we do exchange when the second number is greater than the first number. So I'm going to decrement, as I have done one time comparison. I'm just going to decrement the comparison counter by using a subtract R5 minus 1. That means this is the destination register, this is the source, and this is the source with an immediate value. That means whatever the contents of R5 will be decremented or minus 1, and the result will be stored inside the R5. That means after this after the execution of this instruction, the contents of R5 will be like 4. See, as you can see here, the contents is 5 before execution. Now the loop has been jumped to here. That means no exchange has been taken place. So the comparison counter has been decremented. Now I'm going to check whether all the comparison between the elements of an array has been done or not. If I have done with that comparison, that means if the comparison counter is 0, I'll just come out of the loop, and whatever the result or whatever the data that is present in the R2 will going to be stored inside the internal memory, or else I'm going to keep on doing the comparison operation in order to find the largest number of all the elements that are present in an array. So I'll check here whether the R5 is being 0 or not. If as it is not 0, as you can see the value is 4, it is not equal to 0, again it will, I'm just giving an instruction that branch if not equal. So if R5 is not equal to 0, then I'm going to loop here, and that means the program counter will going to be loaded with an address of this instruction, of this label. So again I'll come back here. Again, after the first two elements has been compared, and since the first number is larger than the second element, I'm not going to do any exchange operation. Now the first element has to be compared with a third element in order to check whether between these two numbers which is the largest one. So I'm going to do again the same thing. I'll increment. Now actually my the address of an array is pointing to the 3C. That means if we start with the 3 4 here, this location is 34, 35, 36, 37, 38, 39, 3A, 3B, 3C. So now it is pointing to the third element. Now I have to increment it, and then I'm going to fetch the second data. See, now the third element has been fetched into R4 register. Now it is being compared with the first element with the third element. Again the first element is greater than the third element, so no data exchange will going to be taken place. So after the compare instruction, it will jump back to a loop, and one more time I'm going to decrement the counter. I'll check whether the counter has been cleared to 0 or not. If it is not 0, I'll do the next comparison. That means the first element with the fourth element. See, now I'm going to compare this 4 with 3. Again the first element is greater than the fourth element, so again no data exchange will going to take place. Again I'm going to decrement the counter. Again I'll check whether it is been 0 or not. If it is not, again I'll come back. Again I'm going to fetch the fifth element, that is A into this register R4, as you can see here 4 4. Now we have to look into here. See, now the first element will be comparing with the fourth element. Now the first data is smaller than the second data. Now actually the data exchange will going to take place. See, now what I'm using is, I'm just ignoring the contents of R2. Why? Because I'm just concentrated only on the result register. That's why I'm just moving this result to the R2 register, where I'm going to keep my result, from which whatever the data that has been reside inside this R2 after the execution of the complete program, that result will be stored inside the internal memory. That's why I'm just ignoring whatever the contents of R4. Because why? Because each time while do the comparison, the next element has to be replaced with this number. So that's why I'm just not focusing on whatever the data that is present in the R4. I'll concentrate only while doing the comparison between R2 and R4. Since, as I told you, this A is greater than, A means 10, you know that in decimal A means 10. So this 10 is greater than 4. That's why the data has been exchanged. As you can see here, the first element has been exchanged with the 4 element. I'm just replacing the first element with a fourth element, and then I'll start again. I'll continue my comparison instruction. Again I'll make the counter. Since one more element is present here, the counter is 1 here. Again it is not equal. Again I'm going to fetch the last instruction to the R4 register, last data into the R4 register, which is 8888 to the R4 register. See, now again I'm going to do the comparison between AA and 88. Obviously AA is greater than 8888. That's why no exchange or no replacing of a first element will going to take place. So as you can see here, it will come to here. So now the counter will be decremented as it is 0 0. You can check the state contents of flag register in the CPSR register. That means once it becomes 0, the 0 flag in the CPSR register will set to 1. So when set to 1, what happens, the BNE instructions will going to look for whether Z is equal to 0. If it is 1, it will just come out of the loop. Now it comes out of the loop. Now whatever the variable that has been defined to hold the address of the result, that will be loaded into an R4 register. See, now since it is being defined in the internal RAM, the address will start from this location. I'll execute that. As soon as this instruction get executed, you can see the R4 register will going to be updated with that address, which is 4000. That means the starting memory location of the internal RAM. Now in this instruction, this LDR is used to load the register, whereas this STR instruction is used to store the contents of R2 into the address which is pointed by the R4. So now whatever the result that is being stored in the R2 will be placed in the memory location 400. So I'll just go to the internal RAM location 4000. So before executing this instruction, the contents of the internal RAM is 00. As soon as I execute this instruction, whatever the result that has accumulated in the R2 will going to be stored in the internal RAM. See, now this is, so keep in mind that since for simplicity I have taken the all digits as A. So if you are going to use some other number like 1 2 3 4 like that, it will going to use a little NDN method in order to store into a internal RAM location. That means lower byte will be stored at the first memory location, and then these numbers will be stored on the next consecutive memory location. So this is how we are going to find a largest of a largest number in a given array. So now in order to find the smallest number, so in this program we just find out how to find out a largest number in a given array. If we want to find a smallest number, only thing is we have to change this instruction to BLS. That means it will going to compare, and what we were doing in our previous program is we are going to exchange the data if the second number is larger than the first element, then we were replacing that first element with the largest number. In this number we are going to do the vice versa. If the first number is larger than the second number, or else if the second number is smallest than the first number, we are going to replace that first element with the smallest number as soon as we do a comparison operation between all the elements of an array. This is how we are going to just in simple way, if I want to tell that the smallest number will be compared, the smallest number will be compared with all the elements of an array. If it is if you find out that the first element is larger than the second element, you are just going to replace it. That's it. Let's check. I'm going to save my program. I'll run this. So you are just finding a smallest number here. The name, it doesn't matter. Whatever you give it, the program will going to run it. So now, so within this array, the smallest number is 1111. Let's check. I'm going to run the program. Again, I'm going to initialize the comparison counter, which is of n minus 1 time, that n, where n is the number of elements in an array, and then I'm going to store this array address inside R1 register. Now I'm going to fetch the two elements, the first and two elements. I'll show you what is the memory location you have to go into in order to find the array numbers, array elements, that is 34. So I'll go to 34 here. If I go into that memory locations, you are going to find the elements of an array inside this memory location. So the first two elements, that is 4 and 2 will going to be loaded inside R2 and R4 register. So in the first instruction you have got the first element, and this instruction you have got the second element in the R4 register. Now I'm going to compare these two instructions. As you can see, 2 is smaller than the first element. As I'm going to compare the smallest number with the each element in an array, I'm just going to replace this R2 with the value of 2. Now as I'm giving an instruction that is ls, branch if lower, so it will going to jump. So if it is the loop is if the second number is if the first number is smaller than the second number, it will going to jump to the loop. That means there is no replace of data will going to take place. I'm just going to do the next comparison operation. In this example or in this comparison, the first element is larger than the second element or second number. That's why we have to replace this first element with the smallest number. Now with this instruction, that will going to happen. As you can see now the 444 has been replaced with the smallest number. So the larger number is replaced with the smallest number, and again I'm just comparing the smallest number with the remaining elements of an array. So now I'm going to decrement the counter. I'll check whether that has been cleared to 0. As you can see, whenever the value of R5 is greater than 0, the 0 flag is set to 0. When it become 0, the 0 flag will going to become 1. You can keep on monitoring that flag register. Now I'll do the second comparison. Since it is not equal to 0, it will going to again jump back to a loop where we are going to fetch the third element, which is 1111, and it will be placed in the register R4. Now I'm going to compare the first element or smallest number that has been found out by comparing the first two elements with the third element. So again the first element is greater than the third element. Now we have to replace this number with this smallest number. So that is what it will going to happen when you do compare. It will check for a lower number. That means if the first number is smaller than the second number, I don't want any replace has to be taken. It will just decrement the counter in order to do the next comparison. In this example or in this scenario, the second number is smaller than the first number, so I have to replace this first element with the smallest number. So I'll do the same thing. See, now the largest number has been replaced with the smallest number. After doing that, I'm going to again decrement that counter. Since it is 3 and not equal to 0, it will again jump to the loop where we are going to fetch the fourth element. Again I'm going to do the comparison operation between 1 and 3. Since the first number is smaller than the second number, no replace of data has to be taken place. So this instruction will not going to executed. After this instruction, it will just jump to the loop 1. See, as you can see, it jumps to a loop 1. So again I'm going to decrement the comparison operation, again decrement the comparison counter. Since it is not equal to 0, it will again jump back to the loop. The same thing will going to happen by fetching the fourth data. Since it is the smallest number, the remaining elements will not going to be replaced with the smallest number. As you can see, the 1 is the smallest number among all the elements that are present in an array. So the next in next consecutive instruction, no exchange of data will going to be taken place. But still, in order to check all the elements, the counter will going to run. As soon, now you can see that as soon as I run the subtraction instruction and make R5 decremented by 1 each time, now after all comparison or all iteration, the counter has been set to 0 0. Now the 0 flag has been set to 1, as you can see here. Now as soon as the 0 flag sets to 1, this loop will going to end, and it will going to come out of the loop, and the address of this variable result will be stored inside the R4 register, which is nothing but your internal RAM location. This address will be stored inside the R4 register. You can see here. So after executing that number, the last element will be replaced with an address for internal RAM address, which is the starting address. Now if I go here to that address, internal RAM address. So you can see here whatever the result that is, the smallest number of an number within an array will going to be stored inside this internal RAM location, as you can see here. One more thing you have to keep in mind, that for simplicity I have taken all the element as 1 1 1 1. If you take a different numbers, the numbers will be stored in a little endian method. That means the smallest number will be stored in the first memory location, and then the consecutive numbers will be stored in the next consecutive memory location. This is how you are going to find the largest smallest number among the elements that are present in an array. This is how you are going to find the largest and the smallest number using a program. Keep in mind that only the instruction that you are going to exchanges, both the program works as one and the same. Only thing is you will just change this BLS to BHI in order to find the largest number, and you have to change it to BLS in order to find the smallest number. Hope you understood. Have a good day. Thank you.